Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation with, as you can see, two different bases. So what our first step is going to be is we're going to expand our right-hand side here. We have 5 to the power of x plus 2. And remember, let's say we have a to the power of b plus c. An important property of exponents is that we can change this into a to the power of b times a to the power of c. Because remember, when we're multiplying exponents, we add these two. So all we're doing is we're simply reversing this. So that's what we're going to do to 5 to the power of x plus 2. We're going to reverse it back to its original form and expand it. So 5 in this case is a, right? So we have 5 to the power of b is x, times 5 again, to the power of c, which is 2. And this is still equal to 2 to the power of x. Now, 5 squared, as we all know, is 25, right? So this is 5x times 25 equals 2 to the power of x. Now what we're going to do is we're going to divide both sides by 5 to the power of x. So if we divide both sides by 5 to the power of x, well, for this side, these two will cancel out. So on our right-hand side, we'll just have 25. And on our left-hand side, we'll have 2x over 5 to the power of x. And this can actually be written as 2 over 5 whole power x. And this is equal to 25. So now what we're going to do is we're going to take the log base 2/5 of both sides. So we're going to take the log base 2/5 of both sides. Well, these two actually cancel out because remember, the log is the inverse of an exponent. So because this is base 2/5, these two are going to cancel out. So on our left-hand side, we have x equals, and on our right-hand side, we have log base 2/5 25. And this is actually equal to, using the change of base formula, which is an important property of logarithms, log 25 over log 2/5. The change of base formula states that if we have a logarithm like this, log of this equal over, so this equals log of this over the log of the base. So now this can be converted to, let me write this over here, log 5 squared, because we're simply changing the 25 to a 5 squared, over log 2 minus log 5. Remember, when we're subtracting logarithms, we divide. So we're simply just inversing that. So log 2 minus log 5. And this, an important property of logarithms, the power property, states that we can just drop down the exponent here in front of the log. So this can equal 2 log 5 over log 2 minus log 5. And this is our answer in its simplest form. If we want a more simpler form, we need to use a calculator for that, but this is the most simplest form we can write our answer in. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x equals 5 to the power of 2x. And what we're first going to do is we're going to simplify this right-hand side of it. We have 5 to the power of 2x. And if you guys already didn't know, an important property of exponents is that if we have a to the power of b times c, this can be written as a to the power of b to the power of c, and also vice versa. It could also be written as a to the power of c to the power of b. So what we're going to write this as is, well, let's first write our 3 to the power of x, and this equals 5 to the power of 2 to the power of x. Now, 5 to the power of 2, as we all know, is 25, right? So this is 3 to the power of x equals 25 to the power of x. Now what we're going to do is we're going to divide by 25 to the power of x on both sides. So we're going to divide this by 25 to the power of x. And remember, what we do on one side, we do on the other side. So we're going to divide this side by 25 to the power of x. So now we have 3 to the power of x over 25 to the power of x equals 25 over x over 25 to the power of x. And remember, anything divided by itself equals 1. So these two cancel out, and this just equals 3 to the power of x over 25 to the power of x equals 1. Now, whenever we have something like this, and we have our numerator going to the power of an exponent and our denominator going to the power of the same exponent, we can rewrite this as 3 over 25 to the power of x equals 1. Because the x, it just multiplies with all our numbers here. So this is equal to this. And now what we want to do is we want to make our bases the same. So another way to write 1 is 3 over 25 to the power of 0. And that way, both our bases would be the same. So this is equal to 3 over 25 to the power of x equals 3 over 25 to the power of 0. Because remember, this is equal to 1, and now we changed both of the terms so that they have the same bases. And now, because both of these terms have the same bases, we know that their exponents are equal to each other, because if they weren't, then this would be false. So now we could just ignore these two bases and set these exponents equal to each other. So x is equal to 0. And this is actually our answer, because we can't simplify this anymore. This is our answer. X is equal to 0. Now, why don't we plug this in and check? We have 3 to the power of 0 equals 5 to the power of 2 times 0. 3 to the power of 0 is 1, and this equals 5 to the power of 2 times 0 is 1, or sorry, 2 times 0 is 0, and 5 to the power of 0 is 1. So this is 1 equals 1, so this is right, meaning our answer is x equals 0.